Okay, in this video, we're going to go over how to use the geometric mean to find the sides of a right triangle when the Pythagorean theorem won't work. Okay, and that's one of the values of using the geometric mean. Now let me show you why the Pythagorean theorem wouldn't work. You notice that in this right triangle, we don't know the x, or this side. We could label this side A, for example. We don't know this angle here, and we're just going to label this side rather, and we can label this y. But we do know the hypotenuse, which is 1 plus 9 or 10. Now recall that in the Pythagorean theorem, we would say that a squared plus b squared would be equal to c squared. But we have two variables, so the Pythagorean theorem won't work here. Now what could work, however, is something called the geometric mean. Now, I've already taken liberties here and drawn a couple of lines in here, but to use the geometric mean, what you would do is actually draw a perpendicular line from the right angle in the larger triangle and form a perpendicular, so you have two small right angles there. And the geometric mean works on the notion that once you've done that, and this line, by the way, is called an altitude or a height, okay? Altitude or a height. Once you've drawn an altitude or a height inside of a right triangle, you've divided this triangle into two smaller, similar triangles that are similar not only to each other, but to the larger original triangle. So essentially, you've created three smaller, similar triangles, and they're all right triangles as well. So in other words, the proportions, and similar means that, remember that similar means that the sides, corresponding sides, are proportional to each other. Okay, so let's see if we can solve for x and y using the geometric mean. The first thing we'll do, let's try to find x, okay? So we're going to do that. Now, whenever I use the geometric mean, I take the three triangles that are in here and I just draw them all out. So it's a little bit easier to see. And let me show you what I mean by that. So I'm going to start with the very large triangle ABC, all right? So let's just sketch out ABC. And again, you don't have to worry about it being the exact same lengths or anything like that, because we're not really worried about that. We just want its labels. So in ABC, I know that the hypotenuse is 10, okay? And I notice that between A and B, that would be the x, and between B and C, that's the y. Now the second triangle, we'll just make the second largest one, which is that one right there. And I'm going to draw it so it looks like that. Now let's make sure that we label things correctly. It looks like right where the 90-degree angle is, we're going to call that D. So I'm going to call this part D, okay? If I follow the short leg, it goes up to B. And if I go down the hypotenuse of that triangle, I get down to C. Now let's go ahead and label what we know. We know that the hypotenuse in this one is Y. And we know that the long leg between D and C is 9, okay? We don't know this one, although I'm going to call it H just for the heck of it, for height, all right? So let's just call it H, just so we can put something there. And finally, let's use the third smallest triangle, this one right here. And again, I know that right where the right angle is, we can call that D. So we'll call that D. If I go up the short leg, it looks like it's A, so that would be here. If I go down the hypotenuse of that one, it would be B. So we're going to go name that here, okay? Now let's label what we know here. We know that between A and D, all right, is 1. So I'm going to put that as 1. We know that the hypotenuse here looks like it's X, so we'll do that. And it looks like between D and B is what's called the height. Okay, so what I've done is I've broken out these three triangles from this one. And that's an important step to do, because otherwise you'll get confused about what's going where. Okay? Now, the geometric mean says this. if I'm trying to find a particular variable, let's say like the x, all right, and I want to find x in this one, I have to use the two similar triangles that both have x in it, all right? And I also have to use the corresponding sides that have x in it. So if I look at these two triangles, it looks like hypotenuse and short side, hypotenuse and short side both have x's, and that's all, and just some numbers, and that would be helpful. So this is what I'm going to say. Hypotenuse is to the short side as the hypotenuse is to the short side. Okay? Now let me just make that a little bit bigger so you can see it. Now, I can basically solve for x. Now, use your algebra. X times, we'll do cross products, all right? X times x is x squared. 10 times 1 is 10. Remember that to solve for something that's squared, you need to take the square root. And I end up with x is equal to the square root of 10. Now, you can just leave it as the square root of 10, especially since there are no units, or you can just guesstimate what that is, right? And the square root of 10 looks like it's somewhere between, it's a little bit like 3.1, something like that. But we're just going to leave it as the square root of 10, okay? So we've just solved now for x. So let's go back up here, and we'll just say the x is equal to the square root of 10, okay? Now let's solve for y. Find y. And again, we have to look at our three smaller triangles and do the same thing. Which two triangles have y in it? It would be these two here, right? And then again, we want to use corresponding sides that will just have y and no other variables. So I'm going to say hypotenuse is to long leg as hypotenuse is to long leg. Okay, so let's try that. 10 is to y ratio as y is to 9. Now again, you'll notice that if I've done this correctly, and let me just move this over slightly. If I've done this correctly, you'll see always that the variables are in the numerator and the denominator, opposite each other. And in this case, they're, again, opposite one another. So it looks like I'm doing something right. So let's go ahead and solve for this one. Cross products, that gives me 90. Cross products gives me y squared. Again, solve by taking the square root. And I get the square root of 90 is equal to y. Now again, you can't leave something like square root of 10 is as simple as it's going to get, right? Because when I divide square root of 10, I get square root of 2 times the square root of 5, and both of those are prime numbers, so it's not going to get any simpler, all right? But the square root of 90 actually can be simplified, because look what happens. I can do the square root of 9 times the square root of 10. We already know that the square root of 10 is prime by itself. Not prime, but, can't be divided up in simpler forms that would lead us anywhere. The square root of 9, though, is 3. And then radical 10 just remains radical 10. So I'll call that step 5, step 6. So y would be equal to 3 radical 10. Now let's just go back and plug that in to our answer. Y is equal to 3 radical 10. Okay, now that's all we needed to find in this particular problem. You could also find the height if you'd like, but I'm going to leave that up to you to see. Well, actually, you know what? What the heck? Let's just go ahead and solve for the height. Okay, so let's just find h. Although we really don't have to, because we've already solved for the Pythagorean theorem. We got this side squared plus this side squared is equal to 10 squared. You know what? And let's just check. So forget finding h. Let's just go ahead and see if that's actually true. So we know according to Pythagorean theorem that x squared plus y squared would equal to the hypotenuse squared. So let's just go radical 10 squared plus radical, or plus 3 radical 10 squared should be equal to 10. 1 plus 9 squared. Let's go ahead and solve this. The square root of, the square of the square root of 10 would just be 10. These just disappear. I'd have to square 9, or 3 rather, to get 9. The square root of squaring the square root of 10 just gives me 10. And that's just equal to 100. That gives me 10 plus 90 is equal to 100, and sure enough, 100 is equal to 100, which means that my two answers are correct. Okay, I hope that was helpful.